Yes. Hello, good morning students. Today we'll start the chapter circle. One of the very most and heavyweight chapter of your textbook, that is circle. Let's discuss the first property of circle. A tangent at any point of a circle is perpendicular to the radius at the point of contact. So this will read a tangent at any point. Now what is tangent? So first we'll draw a circle. For example, this is your circle. So what they are saying, a tangent. Now let us discuss first. What do you mean by tangent? Tangent is a line which touches the circle only at one single point. So let's say this is my line. Line touches the circle at one single point. Let's say my line L is touching the circle at point B. The point of contact of circle as well as this line is what? Point B. So what this line becomes? A line which touches the circle only at one single point. Such line is called tangent. So it means this becomes tangent. Clear everyone? A line which touches the circle at one single point. Such lines are called tangent. So this becomes my tangent. Now next. At any point of a circle, so tangent is at the point of P, is perpendicular to what? To the radius. Now from that same point B, this is the point B, from this B if I draw a radius, right? Let's say my center is C. So CB is what? CB is my radius, right? And B is what? B is the point of contact. What is L? L is the tangent. So a tangent at any point of a circle. So this is my tangent. Point is B is perpendicular. This tangent becomes what? Perpendicular to whom? Perpendicular to the radius. So it makes a right angle with the radius. Clear everyone? Which radius? Can I draw one more radius? Yes, I can draw one more radius. One more possible. How many radius can we draw here? We can draw here infinite radius. So will this tangent be perpendicular to all the radius? No, it won't. Then it will only perpendicular to that spatial radius which is drawn from this point of contact. So from one point you can draw only one radius from this point of contact. So this tangent is perpendicular to the radius which is drawn from this point of contact. Clear everyone? So let's say if I am taking a point A here. So this will give you a triangle ABC, where AB is what? Perpendicular. BC is what? Base. But what I can see, line L was what? It was my tangent, and this BC is what? My radius. Right? So this tangent is perpendicular to this radius because this is the only radius which is drawn from this point of contact. This was the first property. The property is a tangent is perpendicular to the radius drawn from the point of contact. Clear everyone? This is my first property. Hope you all have understood. So what this property says you? A tangent is perpendicular to the radius drawn from the point of contact. You know, a tangent is perpendicular to the radius at the point of contact. So this is your first property. Clear all? Now let's see the second property. A line perpendicular to a radius at its point of contact, the circle, is a tangent to the circle. So what they are saying? A line is perpendicular to the radius. So let's say first we draw a circle. let's say this is my circle, right? We need to draw a radius. So I am drawing a radius. This is my radius. Next, what they are saying? We need to draw a perpendicular to this radius, but where? At its point on the circle. Where this, for example, now this M is my center. N is the point where the radius touches the circle. Where the radius touching the circle is the point N. Now what they are saying? Look, a line perpendicular to the radius at its point on the circle, right? At its point on the circle is a tangent. So I need to draw a line perpendicular, and that line, it should make perpendicular on the same point of contact. If it is perpendicular, it means the line which I have drawn. Now this line becomes what? Tangent. Clear everyone? What is the condition? If this line makes perpendicular, if this line is making perpendicular, so such line is what? Tangent. Clear everyone? That was the property. Look, a line is perpendicular. So this is my line. It was not tangent earlier. Earlier it was just a line. So a line is perpendicular to the radius at the point of contact. Such line becomes tangent. Clear everyone? So a line is perpendicular to the radius at the point of contact is tangent. So that is my second property. Now we'll read the third property, one of the very most important property of first exercise. Okay students, let me explain you this property. Tangent segments drawn from an external point to a circle are congruent. Now what it says? Tangent segments drawn from an external point. It means we have a circle, right? Let's say this is my circle, and we need to draw a tangent. But from where? From a point out of the circle. So I'm taking one external point. Let's say this is my external point. So from this point, I can draw a tangent. This is my first tangent. PM, right? And this is my second tangent. PN. Now what this question says, tangent segments. Look, this one is what? This is my tangent. Why it is tangent? What I told you about tangent? Tangent is a line which touches the circle at one single point. Look again, tangent is a line which touches the circle at one single point. It means this PN is touching the single point N. Similarly, this PM, the contact point is what? M. It means this PM is a tangent. Similarly, PN is also tangent. Both are tangents. Right? Now what I can see both the tangents are drawn from the same point P. Right? Since it is drawn from the same point P, so the length of both tangents, if we take the measurement of this tangent, suppose if this measurement, for example, if the length of this tangent is 10 centimeter, then one more tangent drawn from the same point on the same circle, this also has to be 10 centimeter. Clear everyone? So the property becomes tangents drawn. Look, tangents drawn from the external point to the same circle are what? They are congruent. It means tangent PN is congruent to tangent PM. This is my third property. Understood all? The first property is what? Look, the first property, a tangent is perpendicular to the radius at the point of contact. Now second property, a line is perpendicular to the radius at the point of contact. It is tangent. Now third property. Look, tangent segments drawn from the external point to the same circle are congruent. This is my third property. Hope you all have understood 1, 2, 3. All three properties. These are very important properties, students. These we will use in practice set 3.1. Very important. To solve 3.1, you must have to understood all three properties. Hope I have done my best to make you understood these properties. Thank you so much.